Hello everyone. I want to take a look at an example where we're going to find the length of an arc. Real quick before we do that, just note that the length of an arc and the measure of an arc are two different things. In my example here, I am looking at arc AB, so the arc from A to B here. The measure of this arc is 60 degrees. The measure always matches however big this central angle is. Now the length of an arc, this is actually a number. It's a linear measurement. So if my radius is 8 centimeters, how many centimeters long is this arc? Okay. Arc length is just a piece of the entire circumference of the circle. So essentially what we're doing is I know that 2 pi r gives me the length all the way around the circle. I just want a part of that. And what's going to represent the part is this angle. So 360 degrees makes up the entire circle. 60 out of the 360, that's going to be proportional to the length of this arc compared to the entire circumference. So what we end up with is the arc length of AB, that's going to be equal to, so the measure of this arc over 360. Okay, so in this case, it's going to be 60 over 360. This tells me the piece of the circle that I'm looking at. And then we multiply that by 2 pi r, which gives me the entire circumference. All right, so let me plug in some things here. So we have a measure of our arc is 60 degrees, so 60 over 360. And then 2 pi and our radius is 8. So if I do a little simplifying here, 60 over 360 is equal to 1/6. And then 2 times 8, we get 16 pi. So I have two different parts here. And I think the thing that makes this the easiest to understand is if we understand what each of these parts are talking about. So on the right, this 16 pi, this represents the entire circumference of the circle. So all the way around, that length. This piece, we got this from the measure of the arc over 360. So what this tells me is I'm only looking at 1/6 of the circle. So if I want to find the arc length, I don't want the entire 16 pi. I only need 1/6 of that. So this arc from A to B makes up 1/6 of the entire circle. Okay, so then if I just multiply these together, I can simplify a little bit. 16 over 6. Let's see if we can take a common factor out of 2 there. So we end up with 8 over 3 times pi. That doesn't really tell me too much right now, so let's get just a decimal approximation of that. So I'm typing that into the calculator. I end up with about 8.4 centimeters. So the length of this arc is about 8.4. If I were to multiply that by 6, I would get the entire circumference of the circle. So just using a couple things we already know, the formula for circumference, we already know that. The measure of an arc over 360, that's just telling us the piece of the circle. And then combining those two things together, we get arc length.